Hello everyone, welcome once again. In our last session, we talked about the introduction to the measure phase, wherein we discussed what are the key activities of the measure phase and what are we going to do. So to start with, as we said in the last session, we shall be collecting data, and that data will be used to analyze the customer's pain and problem that the customer may be facing, just like a doctor collects the data. So to start with, it talks about the type of data, because the type of data is the most important thing in the world of Lean Six Sigma. As you can see on the screen, we are here talking about two types of data. Now, you would have seen, or you would have maybe read in any of your subjects, that we have a quantitative data and we have a qualitative data. So that's a typical two categories of data. In our world of Lean Six Sigma, we are not talking something very different, but here we are giving them different names, and the characteristics is also a little different. So here when I say quantitative data, it talks about the continuous or the variable type of data. Now the continuous data, which we use a lot in the Lean Six Sigma methodology, which we actually use to collect the data, it talks about any data that should have a measuring unit, a measuring scale, and if you break it into smaller pieces, it still remains. It still has a meaning. For example, distance. Now distance can be measured in various ways. If we talk about very big distance, we're talking about light years. For example, the distance between Earth to Moon or Earth to any big galaxy, it would be light years. If you break this distance into smaller piece, it would be different mile. Smaller distance is mile. Another smaller distance will be kilometers. Further smaller distance will be meter, and then yard. Further smaller will be feet, further smaller will be inches, and then centimeters, and then millimeters, and then nanometers. So you see, every smaller part of the distance still has meaning. It still has a measuring unit and a measuring scale. So this is the type of data as a continuous data. Some other example can be length, width, height, temperature, age, experience. They are all continuous type of data, we call it. And there's another type of data which we call it the discrete data, which we said qualitative type of data, but here we call it discrete data or the attribute data. Any data that is counted, now there is no specific measurements for it, that is counted will be a discrete type of data. Discrete type of data may also have the qualitative categories that we'll see in the further in this session. So here basically it will have some categorical data as well. For example, go, no go, yes, no, true, false, day, night, good, very good, bad. So this kind of data will be a categorical data, but will form as an attribute or a discrete type of data. Why it is important to understand the two types of data? Now this is natural, it is common sense also, that different type of data will generate different analytics. That is one thing. But then in the world of Lean Six Sigma, we are using a lot of tools. We have a different set of tools for different type of data. A data type will have different set of tools, and different type of tools will generate different insight and the analytics, and will have different results altogether. So while you are collecting the data, the important advice is to understand what type of data are we gathering. So the question that comes in, what type of data should we gather then? The type of data we should gather, we should try to gather as much continuous data as possible, because that's what we require, right? Which has a measuring unit and a scale. Analytics will be even better on the continuous type of data. But in the real world, getting a continuous type of data is not that possible. In fact, most of the time the data you will be gathering will be a discrete type of data only. And this becomes a trick how to convert that discrete type of data into a continuous type of data. This is a more of a practical situation and a question and a situation that we try to deal in the real world when we work on a project. If you see in this slide, we're talking about some more examples of type of data. For example, the attribute or the qualitative data that we are talking here. So yes, no, go, no go. It's called the binary type of data here. And the quantitative type of data is what we are talking here, which has a measuring scale and unit. Some examples can be the money, pressure, conveyor speed, material feed rate, time pressure, and all that thing. That's all type of the continuous type of data because it has a measuring scale and a unit. If I talk about some more examples from different industries, if you look at this slide, like most of the time we struggle with understanding on the percentage type of data or the ratio type of data, as that's the most important, because it can be tricky to understand will percentage be a continuous data or will percentage or ratio be a discrete type of data. So to give an example, let's say we're talking about the continuous type of data. So we see in the slide here, we're talking about from the service industry where most of us will be, elapsed time to complete a transaction, time remaining to complete a transaction, average length of the phone call. Now that's a typical continuous type of data because here we're talking about the time as a measuring unit here. And if we talk about the discrete data, now discrete data here, it can be a percentage or a proportion, the ratio. Now an example can be population of late application, incorrect invoices. Now I can say a total proportion of invoices or total proportion, or let's say in a class if there are 100 students, how many students have passed, 60 passed, 40 failed. So I can say what is the proportion of failed students with respect to the overall student who took the exam. So that proportion will be a discrete data here in that case. That's how we understand it's a discrete data. And number of students is a discrete data because we have to count here. The moment we break that count, the moment we say that 25 cannot be 24.3, we cannot have 24.3 students. That's not a count data. That's where there is no relevance of 24.3 students. That's where it does not become this here doesn't make any sense in our case. So we need to be very careful while we are trying to understand the data type, whether it's a continuous data type or discrete data type. Now discrete count data, as we just discussed, number of applications, errors, complaints. Discrete attribute type of data, like type of application, type of request. So any categorical data will always be a discrete type of data. Like number of balls, we have around, let's say 30 balls in a packet. What are different colors of those balls, the categories of colors of those balls. So those categories will be a discrete type of data here. Now there is something called as ordinal discrete data, as you can see in the slide, the last row here. Ordinal discrete data will be where the categories are in order, like 1, 2, 3, 4, 5. Rankings or ratings is a completely ordinal discrete data. We'll have A, B, C, D, E. So whenever categories follow a natural ordering, it's called a ordinal type of data. Excellent, very good, good, satisfactory, not satisfactory. These are the 5 categories, but they are in an order. So that's a natural order. So that is also called a ordinal discrete data. So that is about the types of data, and it's very, very important to understand type of data, as I mentioned earlier also, as the type of data will determine which tool you will use. As in when we grow further in the Six Sigma profession, we go through more advanced training. If I talk about the green belt training or a black belt training or a master black belt training, there are so many tools, and each of that tool will be required to work on a separate set of data. So it's very important to understand the type of data now, and then we can choose the right set of tools for our data, and so that we can generate the relevant insights, and that insight will help us to drive further. Because whatever we do today, because that's the foundation, the first step, when we decide the type of data, that will determine the entire analytics in the measure phase. We'll get the baseline and current performance of the process based on the type of data, and that will help us to move to next phase, analyze phase, where we'll try to find the root causes, and after that we'll go to the improve phase where we'll design solutions, and then in the control phase we'll build the sustainable control plan. So everything is dependent upon the type of data we are gathering here. So it's a very important thing. We have to deal with it very, very carefully. So this is all about types of data, 2 types of data, discrete type of data and continuous type of data. Thank you for watching. This is Shivendra Sharma.